Our next guest was recently here teaching us how to have fun with electricity. He came back a few weeks later to teach us how to have fun with rockets. Tonight, he's here to teach us how to have fun with nitrogen from New York University, a fun place to attend school. Please welcome Professor Richard Brandt. Richard, how are you? Nice to see you. All right. First of all, let's just start at the top. Is this, how dangerous? Is it dangerous, this stuff? What do we...
Oh, no, this is really relatively quite safe. I would say the chance of danger is less than 1%.
Less than 1%?
Less than 1%? That's not good enough for me. Honey, let's get the hell out of here. We just got married. We're getting the hell out of here. We're too young to die. Don't look about that. Move out of our way.
I don't know what to say. I'm just sick about this.
That was a setup, wasn't it?
No. All right, back to the nitrogen. We have two gurgling cauldrons of liquid nitrogen.
Right, that's what we have.
Isn't this rocket fuel?
It could be, yes. It's many things.
But isn't this very dangerous?
No, it's not dangerous at all. 1%.
Okay. But is it illegal? You can't have this stuff here, can you?
Oh, you can have it if you don't drink it or something like that.
No, but could I go and buy liquid nitrogen?
If you had enough money, yes. You could actually buy it. It's about $51 for a big tank full.
Oh, so relatively inexpensive.
Relatively inexpensive.
Okay, now what's the practical application of this?
The main point is it's very cold, really cold.
Yeah.
It's about as cold as you can get without very sophisticated machinery.
In Fahrenheit?
In Fahrenheit, it's about minus 231 degrees Fahrenheit.
Now, what's absolute zero?
That's about minus 460 degrees Fahrenheit. So you're pretty much three-quarters of the way there.
Now, absolute zero, that's where molecular motion ceases?
How do you know that?
What? I mean, what?
That's true. No, you're right. You're right.
I'm not here delivering meat. What
no. I thought I was teaching you, but you're right.
Okay.
Our motion stops, and we'll use this very cold temperature to transform things from their normal state into new states where they're very cold and brittle and have rather different properties from ordinarily.
Okay, now one more question here before we begin the demonstration. What is the practical application of this other than rocket fuel, or is that it?
Oh, no.
And freezing things.
Right. Low temperatures are very important in physics. Often they're used to improve conducting properties of material, making them into so-called superconductors. So that's a very efficient way to transmit electricity and to make magnets.
Really?
Yes.
I didn't know that.
Right, a whole branch of physics uses low temperature.
Now, what about when you're dead? Does molecular motion stop then, or is it still going on?
Well, it goes on to some extent as you decay, but as long as you're not at absolute zero, there'll be some molecular motion, sure.
No kidding. Now,
really.
Even, for example, in the iron or steel head of this, there is molecular motion?
Of course.
Okay.
Everything except something at absolute zero is moving.
All right, and tonight we're going to take a few things
everyday
as close
substances
to absolute zero as we can.
As we can, conveniently.
And it's safe.
Pretty safe, yeah.
Okay.
Here's a long stem rose.
Yep.
Ordinary.
Yep.
Put it in.
So it's splattering. Now, when it hits your skin, will it hurt?
It hurts a little, yeah. It's pretty cold, so we'll try to avoid that. We have gloves.
Why don't you put the gloves on?
Well, I don't need them yet.
Oh, okay.
Here's some grapes.
I'm going to set a good example for the kids at home.
Great.
Folks, go out and get them a tank of nitrogen, and oh, this is like fonduing, isn't it?
Yeah. Obviously, this is used a lot in Frankenstein movies.
Now, you spilled this stuff all over the table.
Oh, they'll clean it up. Okay. Here's banana.
The banana?
Yeah.
Okay.
Okay, and we'll do...
Ooh.
Don't worry.
All right.
Okay, let's begin with the rose, which should be pretty cold by now. Why don't we take it out? Why don't you smash it against the table? See what happens.
Smash it against the
table? Hit it hard.
Wow. That's unbelievable.
That's quite a change.
My God. Now, what would be the difference if you took it to absolute zero? I mean, is there any perceptible difference?
No, if you took it to absolute zero, the effect would be pretty much the same. Once it's cold enough so that it reaches its freezing point, then you get effects like that.
Now when people, they were trying to freeze people, and I guess they did to a certain extent, was this pretty much what would happen if you froze?
Yes, the idea is to stop your molecular motion so you don't age when you freeze people, of course.
But if they would bump you in the container...
Right.
Get it. We're,
But it has practical applications. Doctors use this to remove warts from people by freezing them off.
Okay,
Yeah.
well, let's pull something else out of the magic
Let's stick in a late night sponge.
All right. Well, what happened to the banana and the grapes?
Oh, we'll get that out now.
Okay.
Why don't we take out this banana, and why don't you use it to hammer that nail in the wood?
Can I touch it,
you
Art?
can touch it.
Hammer a nail in?
Yeah, there's a nail. Right.
Well, I'm sure I was going to use
Oh, you put a hole in the banana. All right. Let's... Okay, I told them to get wide head nails, but we'll come back to this. It needs to be
refreeze
cold.
the banana.
Let's look at the grapes. Here's the grapes. Now take this hammer. Don't touch them. Yeah. Smash the grapes. Don't touch the grapes.
Here's a little. Oh, boy. Oh, my God. They're like marbles.
Yeah.
Now, could a person eat this, or would it be just way too cold?
Oh, it'd be way too cold.
Way too
yeah,
cold.
you
Now, would this ever thaw from
Yes,
its...
sure.
It would thaw back to normal?
Yes, that's the second law of thermodynamics. Everything.
How long would it take it to thaw back to
Oh,
normal?
just a few minutes.
Yeah. And it would be fine then?
Oh, absolutely. Fine.
No
It would be
structural thing?
fresher than a grape that wasn't put in this because it was not decaying.
Is this how cold they make frozen corn and stuff like that?
No, not this.
Okay. All right. Okay. Here, I'll just go ahead and finish this off. What the hell? You can take the banana out.
You should. There's a lot of promise. All right, here's
We'll
the
be
banana.
needing the banana now.
All right, you want to try it? Oh, we don't need the
No,
banana.
here's another nail. I got another nail.
All right, watch your finger. That's the 1%. You put them on.
Bad sakes.
You really like this.
That's amazing.
Put on the other glove,
All right.
and I'll give you this late night sponge, and you can...
Why didn't you tell me to put the glove on before you handed me the banana?
That's a good question.
Yeah,
That's a very
yeah.
good question. Yeah, my students ask questions like that. Here's a late night sponge. All right, you're
Well,
safe.
shake it
You're
out.
safe with me. Why don't you crush it?
Crush the late night sponge.
Crush it right now.
Wow. That's unbelievable.
Okay.
Wow.
Now, here we have a lead bell. Hardly rings at all, right?
A lead bell, but what are those?
It's just lead, and they don't ring because it's so elastic.
But why do we have bells then? If they're, I mean, I mean,
This is for a demonstration.
all for a demonstration.
Right.
only.
I put it in, and it's going to freeze and become much. Keep the gloves on.
Even the gloves are too cold.
All right, listen. While we're waiting for that, why don't you blow up this balloon?
I'd be proud to.
Okay. And then tie in a knot in the other end. Get it as big as you can.
I will. What's this stuff on there? Some dangerous chemical, obviously. And
Nitrogen is inert.
but what's that powdery stuff?
Oh, it's a dangerous chemical. I don't know.
You idiot doing. The girls will be here in a few minutes.
Oh, that's very good. Oh, you've been practicing.
Want to see a duck?
Yeah.
Okay.
That's very impressive. Can you tie that?
No, I really can't. I don't know how to. I can't. I can't tie them.
Neither can I.
Well, what do we? Well, that's not tied.
No, it isn't. Why don't we use one that's already blown up? I didn't know you couldn't tie it. All right, here it goes. Now, watch this. See it shrivel up like that? The air inside is at low temperature, and therefore the pressure goes down very much, so the atmospheric pressure completely crumbles it. With my trusty pliers here, I'll push it down further. All right, see it shrivel up?
Yeah.
I bet they'd like to see it, too.
But why isn't the balloon damaged in this? Why isn't that?
Well, it's the same material. It's just frozen solid.
Okay.
It retains the same molecules. Now, I put it on the table, and now as it cools off, atmospheric pressure is no longer greater than the pressure inside, so it returns to normal.
That's amazing. That's very impressive. That's unbelievable.
Yeah.
All right, what are we going to get to one more? Okay.
Okay.
Yeah.
I'm gonna put
How much time do we have? Oh, we have a minute, so we got
Okay.
time for a couple of these. We'll move
Okay.
along.
Here we bring the bell out again. It's going to be cold, but I'll
Yeah.
come here.
Right.
Okay. And let me put these
Now,
in.
what was the bells? I didn't understand the bells.
Before it didn't ring, and now it rings.
Oh, now it does ring.
Yeah.
I see.
Yeah. Okay. We put these in. Okay.
Do what? We got to get to...
While we're waiting for these,
All right, we're running
here are-
desperately short on
these
time.
are our ice bombs.
Ice bombs. Now we're getting
Water
somewhere.
inside of these lead containers.
Those are lead containers
Yes.
filled with water.
Very tight.
Into cylinders of liquid nitrogen.
The cylinders of liquid nitrogen, so the water will freeze and therefore expand, but
And we'll all be killed, won't we?
no, we have a screen on that, so that'll be pretty nice. While we're waiting for that to happen, let me take this opportunity to thank my helpers, Jim Davis and Howard Goldman from the NYU Physics
All
Department.
right,
who
that's
I've
very
never
nice of you.
mentioned.
This is the third time you've been on the show and the first time you've seen fit to thank anybody.
I've been too busy before, but now we have the time. Keep your eye on that. What do
No,
I-
the ball. Yeah, the
what do
ball.
I have in here?
I don't know. The ball.
Oh, all right.
What happened? But now don't. Oh!
It's okay, it just evaporates. Yeah.
All right. Okay, here comes...
Okay, listen to this. This is a Top Flight XL. Watch how it bounces.
Wow. Like a ping pong ball. Yeah. Okay.
Completely different from before. Now, let me get out this one. Do you want to... All right, I'll do this.
Now, how was that different from the way it would bounce normally?
Because when you freeze it, it changes the elasticity property.
It bounces
so
less or more after it's frozen?
Actually, it bounces less.
Less,
That's why you
okay.
warm up the golf
What do you
balls
get
on
in
the
there?
court.
How are we doing here?
This
You all
is
right?
the second to last thing.
We're getting close. We're getting very
All right,
close,
here we go.
Doctor.
Watch
okay.
this.
A racquetball.
Ready? Watch.
Wow. That's unbelievable.
It's
Could
unbelievable.
You bust that thing?
Yes, that's what I wanted to
Now,
do.
how's the bomb doing?
That'll be ready in another few seconds,
Okay.
I believe. Once it
We're
stops
waiting on the
boiling, then
We
it's
just
going to be ready to
stand
go.
back, you're saying? Oh, okay.
Oh, okay. This one just makes a lot of steam.
Yeah.
Yeah. It won't get on you. All right, let me put another one of these in. Actually, I can mention that although this environment is very different from the one we're used to, on the outer planets, they have temperatures like this.
Oh, really?
So this would be a normal state of affairs. Getting ready.
It's still boiling now.
Yeah,
Does
it's
that...
still boiling. When the
Okay.
boiling stops is when it's gotten cold enough to
Okay.
actually explode.
If you're just joining us, we're waiting on a night... Oh! My God.